Hello students, let's see the Mendeleev periodic table. It was Mendeleev who was responsible for publishing the periodic law. For the first time, it is stated that the properties of the elements are periodic function of their atomic weight, or you can say atomic mass. So how he did, student? Mendeleev arranged elements in horizontal rows and vertical column of a table in order of their increasing atomic weights in such a way that the elements with similar properties occupied the same vertical column or group. Mendeleev's system of classifying elements was more elaborate than that of the Lothar Mayers. He fully recognized the significance of periodicity and used a broader range of the physical and chemical properties to classify elements. In particular, Mendeleev relied on the similarities in the empirical formula, properties of the compounds formed by the elements. He realized that the sum of the elements did not fit in with his scheme of the classification if the order of the atomic weight was strictly follows. He ignored the order of the atomic weight, thinking that the atomic measurement might be incorrect, and placed the element with the similar properties together. For example, iodine with a lower atomic weight than that of tellurium. Group 6 was placed in group 7th along with the fluorine, chlorine, bromine because similarities in properties. At the same time, keeping his primary aim of the arranging the element of similar properties in the same group, he proposed that the sum of the elements were still undiscovered and therefore left several gaps in the table. For example, both gallium and germanium were unknown at the time Mendeleev published his periodic table. He left the gap under the aluminum and gap under the silicon, called these elements Eka aluminum and Eka silicon. Mendeleev predicted not only the existence of the gallium and germanium, but also described some of their general physical properties. These elements were discovered later. Some of the properties predicted by Mendeleev for these elements, those found experimentally listed in the table 3.3. The boldness of Mendeleev quantitative prediction and their eventual success made him and his periodic table famous. Mendeleev periodic table published in 1905 is shown in figure 3.1. So what Eka aluminum, what is expected? These are gallium, this one. So you if you predicted 68, and that is how much it is pound, 72, 5.5, 5.9, low, high. So these are what the predicted. Now we will study the modern periodic law and the present form of the periodic table. We must bear in mind that when Mendeleev developed his periodic table, chemists knew nothing about the internal structure of the atom. However, the beginning of the 20th century witnessed performed develop in the theories about the some atomic particles. In 1913, the English physicist Henry Moseley observed irregularities in the characteristics X-ray spectra of the element. A plot of the root of the frequency of the X-ray emitted against the atomic number Z gave a straight line and not the plot of the B versus atomic mass. He theoretically shows that the atomic number is more fundamental properties of element than its atomic masses. Mendeleev periodic law was therefore, according to modified, this is known as the modern periodic law. Physical and chemical properties of elements are periodic function of their atomic number. The periodic law revealed important analogies among the 94 naturally occurring elements, neptunium and plutonium, like actinium and protactinium, are also found in pitch blende. An ore of uranium is stimulated renewed interest in inorganic chemistry and has carried into the present with the creation of artificially produced short-lived element. You may recall that the atomic number is equal to the number of charge, number of protons of the number of electrons in the neutral atom. It is then easy to visualize the significance of the quantum numbers and electronic configuration in periodicity of the element. In fact, it is now recognized that the periodic law is essential. The consequences of the periodic variation in the electronic configurations, which indeed determine the physical and chemical properties of elements and their compounds numbers from the periodic table, have been devised from time to time. Some form emphasis chemical reactions and valence, whereas the other is stressed the electronic configuration of element. A modern version, the so-called long form periodic table of the elements, in the most convenient and widely used. The horizontal row, which Mendeleev series are called periods, the vertical column groups element having similar properties, similar outer electronic configuration in their atoms, and arranged in vertical column, referred to as group or families, according to the recommendation of the International Union of Pure and Applied Chemistry, IUPAC. The group of the unnumbered from 1 to 18 elements. The other notation group first is third A, seventh A, eighth 1B. These are there. There are the altogether 7 period. The period numbered correspond to the highest principal quantum number of the element in the periodic table. The first period contained 2 elements. The subsequent period consists of the 8, 8, 18 these elements respectively. The 17th period incomplete, like the 6th period, would have theoretical maximum on the basis of quantum number of 32 elements. In this form, the periodic table 14 elements of both 6th and 7th period, lanthanoid and actinoid respectively, are placed in separate panels at the bottom. Nomenclature of the elements with atomic number 100 will be studying in the next.